So who am I? I'm Thorsten Butz, and today I would like to talk about privileges, token privileges. You all know the whoami command with its priv parameter. You will see something comparable when you log on to your machine. But we can only do justice to these privileges if we add a second topic, the user account control. We're all used to having privileged and less privileged user accounts. You can switch between these accounts and then typically enter a username and a password. And to me, this reminds me of the substitute user command in Unix systems, abbreviated to SU. Since Windows Vista, there has been a sudo-like mechanism where we assigned two tokens when we log in. This is called the split token process. When we start an application using run as administrator, we switch from one, the green token, to the other, the red token. The split token process has often been misunderstood. And one of the problems is that this special mode has not been given a proper name. Mark Russinovich used the term protected admin once in his articles, and this is the reason why I also use this. A protected admin has the option of starting applications with run as administrator in an elevated mod. You can see now that we got a lot of additional privileges granted on the right-hand side. You can compare this to opening the door to your hotel room. You simply hold the keycard up to the door lock and the door gets open. What is striking, however, is that when we further analyze this, an incredible number of these tokens are set to disabled, as if you still had the card in your pocket. We can see the consequences of this in the next exercise. So let's try something. Let's assume we want to call a WMI method, as in the example that we see here. Suddenly we realize I want to trigger a restart, which of course initially includes a shutdown. And I realize that unfortunately this does not work just like that. You can see nothing happens. But if I activate the shutdown privilege and repeat the whole thing, then all of a sudden I can successfully restart. And by the way, if I had used the sim methods, I would not have encountered this problem. That this is real life. People use the old WMI things. So I'd like to show you this. The script that we've just saw in this demo is, I assume, very well known to you. It was made by Lee Holmes, and we can see a small snippet here. It uses a special technique called pinvoke, or however you pronounce that, and it allows us to address areas of the operating system that we cannot connect to via .NET directly. The special thing about these privileges is that you are assigned them, but you have to activate these privileges in a second step. This is exactly what the script of Lee Holmes does. It's not a second authentication or authorization, it's just a start and an enlightening of the privilege. Let's look at a real-world example. I would like to change this registry value. I can only do that if I take ownership first, but I can only enforce this with the help of the take ownership privilege. I can then change the ACL. This is not possible with set ACL, sadly. The interesting thing about this example script is you can configure something quite interesting with it. And by the way, you get all these examples in the extended version within the repository. So the main question is, why is this a great example? Using the script, you can unblock the Windows Explorer, if I may say so. Windows Explorer does not normally want to be started with run as administrator. Microsoft does not allow this for security reasons, or for what reasons, however. And this leads to the problem that you cannot perform certain actions in the file system. You could do this eventually with Notepad or Total Commander, but not with the Windows Explorer. But I want, as you can see here with the screenshots from Process Explorer, I would like to have an Explorer with elevated rights for demo purposes only. And let's see how this works. First of all, I try to start Explorer with run as administrator. You will see this will not work the way that I like it, because you can, as a standard user, only create folders in Drive C. And of course, I cannot connect to another user profile. That's good. But now that I run my little script, first of all, I need again Lee Holmes' help with the set token privilege. I enable the privileges. And now I can take ownership of the registry and include an ACL. And by the way, thanks to Guy Leach, who I stole a piece of the snippets here, he gave the idea somehow. And from that moment on, you can see it here, I can repeat the exact same action successfully. This time, I can create a file on Drive C, and I also can go into the profile of any user and just copy the files from the other user. This is what I just did. But in real life, this is not suitable because Windows Explorer is not made for actions just like this. It doesn't use the proper APIs. So the real life solution is use simply robocopy. If you call robocopy and you also call the /b parameter, it activates in the required privileges in the background. And finally, if you want to reproduce that yourself, we are again back to pinvoke. You can create your own script, which also uses the proper APIs to behave like a backup program. But then again, you have to use pinvoke, and it's a mess of scripting, very, very complicated. But try that out. I provide a couple of scripts for that. In a nutshell, token privileges must be granted. This is what happens during lock-on. You receive many privileges, but not all as an admin. Most of them are disabled, and you have to activate it in a second step. And for real life, show your students, show your apprentices robocopy. It's an awesome tool. It provides all the things that you need to get to the files that you might not be able to open in another way. Thank you.